Assalamualaikum warahmatullahi wabarakatuh, and a very good afternoon to our presentation panel, Mr. Mazlan bin Mansur and Mr. Lokman Hakim bin Hamzah. My name is Muhammad Aiman Ashraf bin Muhammad Yazid. I'm from 4BMMA, and today I will present to you about my project Sarjana Muda 2, and the title is Design and Testing of Prosthetic Legs. This project is supervised by Mr. Muhammad Rafi bin Omar. Okay, for the introduction, the limb prosthesis has been invented in order to replace the loss of body part caused by disease, accident, warfare, and also natural imperfections since the early birth. Next, the material that are used to make the old limb prosthesis is such as wood, leather, and metal, where the old prosthesis offer the limitation in movement. And lastly, compared to the invention of prosthetic leg, the new prosthetic leg has become more functional and comfortable for victims, amputation victims to use. So the main objective for this project is to verify and learn the best method of data gathering based on the actual leg. Second, to design and optimize based on actual leg measurement to achieve patient's comfort. To able run the analysis on the prosthetic legs, and also to study and improve the existing product prosthetic leg in the market. The scope that will be used in order to support the objective is designing prosthetic legs based on patient's leg. Second, using CATIA V5 software as the medium to design the prosthetic legs. And third, using 3D printer, which is SLS 3D printer, in order to fabricate the prosthetic legs. And lastly, learning the reverse engineering by using CATIA software and testing the final product. So we go to problem statement. The material selection to produce the product is in order to reduce the reduce the weight will be important because it will determine the comfort of the patients. Second, the difficulty in getting the accurate data by using 3D scanner based on actual leg will cause the trouble in gathering the data since the data is not accurate. And lastly, some of the product existed in the market is not really fitted, and this will lead to the patient's discomfort. So this is my literature review. The citation is from Alan J. Thurston from 2007, and this is his statement. Next, we go to the methodology. Figure 1 shows the methodology flowchart. Start with the feasibility study and ended with the analysis. So for the data gathering, I will use laser scanning by scan the craft of the patient's leg by using plaster of Paris. So the advantage of using laser scanning is the data will be more accurate and easy to transfer data into the CATIA and Altair SimSolid software for the designing process and analysis process. So the mechanical design, there are several parts that are involved in the mechanical design, such as interface, socket, pylon, and also foot. And the material selection, several criteria that will be considered in this project, such as the material durability, weight, appearance, and cost. Next, we move to the product design. In this project, I will use CATIA V5 software as a medium in order to draw and design the product. In the figure shown is my 3 concept design that will be considered to be chosen for the final product design. In order to select the best criteria, I will use proof concept selection matrix. So there will be several criteria that are needed to be included in the design. So the highest score of the weight score will be chosen as a final design selection. For the analysis, I will use Altair SimSolid. So I will just import the CAD file from the CATIA version, CATIA software, and import it into the SimSolid, and the result will show the displacement magnitude, von Mises stress, and factor of safety, and much more actually. So for the material selection, I will use nylon powder with code FS 3200 PA. There are several advantages of this nylon powder, such as good recyclability, good antioxidative properties, size stability, and low water absorption, and easy to process, and much more. For the nylon powder, the tensile strength of the material is 48.1 megapascal. The tensile modulus is 1646 megapascal, and it has a melting point where it is 183 degrees Celsius. After making a material selection, we move to the product fabrication. So for the product fabrication, I will use 3D printer SLS 3D printer or selective laser sintering. For the model of the 3D printer, I will use Farsoon SS402P that are available at the FTKMP, and the material is by using nylon powder. So after fabrication product, the final result, I will test it on the patient to see whether the product can hold the patient's load or not, based on and will be compared to the analysis run, and the different result might be produced due to the several factors. For the result and discussion, okay, so this is the result from the analysis run before. So it will show the displacement magnitude. Displacement magnitude is model displace or deflects when the load is applied. So at here we can see there are 2 points, which is maximum and minimum displacement magnitude. The maximum value is 1.54 times 10 power of -1 for the 980.67 Newton or 100 kilogram. Next, we move to the von Mises stress. So von Mises stress is the value used to assess for material to see whether the material can yield or fracture. There are 2 points shown maximum and minimum value. So the maximum stress is 5.3 times 10 power of 6, and minimum stress is 5.57 times 10 power of -5. Both maximum and minimum stress are for 980.67 newtons load applied. And lastly, for factor of safety, in order to get the factor of safety, the material strength will be divided by the allowable stress of the product and the maximum result of factor of safety that have been calculated. So for 60 kilogram or 588.4 Newton, the factor of safety is 15.1, and for load 980.67 Newton or 100 kilogram, the factor of safety is, the value of factor of safety is 9.10. So it can be concluded for the overall result, the product is oversafe because the value of factor of safety is above 3.0. So if the result is below 1.0, the product is totally unsafe. So the suitable factor of safety is 1.0 until 3.0. So for the conclusion and recommendation, so in this project, it can be concluded that making this prosthetic legs can help to bring back the confidence towards the amputation victims. This is to help them to bring their courage to face the world as before. And next, students are able to discover the new method or way in order to gather the data, such as using plaster of Paris and laser scanning. Third, student able to use CATIA V5 software as a medium to create the product and draw the design, and using Alter SimSolid to run an analysis to get the data for the result analysis. And lastly, improving existing prosthetic leg design from the market, such as improving the weight by reducing the weight, and optimize the design to make it look more attract to the user. And for the recommendation, in my opinion, I would recommend to optimize the design in order to reduce the waste of material. This is due to the factor of safety, which is oversafe. So it shows that the material waste for this project fabricating. And lastly, by using lightweight material in order to reduce the product weight as much as possible, and not forget to use the lightweight and strong material for a better prosthetic legs product in the future. Thank you.